Hi, in this lesson we'll talk about Databricks Photon Engine and why it's important, why you should use it, and how it makes your life easier and also reduce your cost. In order to do that, let's first take a look at how Spark internally works. Whenever someone creates code on Spark and then run the code or send the code to the Spark driver to submit, Spark will first parse the code. See if syntax errors, everything works to the specs, everything is fine. Then it will generate something called the logical plan. How it will actually execute this code and the workers, how do you communicate, shuffles, and all these things. It's all decided at this level. Then from this, generate something called the physical plan. And then after all this generated, it comes to the part where it actually executes this plan. This is a high level. There's more steps, but this is the high level steps. Remember, Spark was all written on Scala programming languages. Scala is a JVM based programming language, which means it runs on the JVM, Java Virtual Machine. So what Databricks did is, can we do better? Can we make it faster and more efficient? The opportunity to say is, okay, we can, but we're not going to replace the whole thing, because this is perfect. This is run very fast. There's no advantage of converting it to something else. But this part where the code is actually executed on the worker nodes, we can optimize it. How we do that? By switching to the Photon Engine. What is a Photon Engine? It's exactly the same engine here. However, it's not written in Scala. It's written in C++. So that's the first optimization that we've got. We got closer to the hardware by executing a native code than the JVM code. So we removed one layer of abstraction, which is the JVM. We run directly on the operating system. We don't run through JVM and then from JVM to the operating system. We remove this layer. The second optimization Databricks uses a technology called single instruction multiple data, SIMD. It's not a Databricks technology. This is a CPU technology, CPU architecture technology, where you can process multiple data with single instruction from your processor. Usually when you have a 1 million record, you wanted to sum all of them. We're gonna do a 1 million plus operation, right? Or a 1 million trip from the memory to the CPU to bring the next row to sum it, to add it. So we're gonna do 1 million trip. With SIMD, you will only do one trip. You will fetch 1 million and then do one plus. So the CPU cycle will not do 100 cycle to go back and forth from the memory to the CPU. Will only do one cycle, which is summing the 1 million record, called SIMD technology. Very, very fast technology. And when you use Photon, you could get optimization up to, I think, between 3x and maybe 10x in some cases, or maybe something in the middle, 5x as an average. This is the kind of optimization you would get. And Photon Engine really optimizes your cost. How does Photon Engine optimizes its cost? This is, in order to understand this, you need to understand how Databricks costs. I think we already described this in the DBU lesson, but as you know, your cost is split into two pieces. First piece is called Databricks cost. The second is your cloud hardware cost. It's usually one-to-one most of the time. Not always, but most of the time. Let's say if you pay $10 for Databricks, you're going to pay almost $10 for your cloud, for your hardware. So your total job will be $20. Let's say your job take 1 hour to run. So the duration of your job is 1 hour. You pay $20 in 1 hour. With Photon, your job will not run 1 hour. Your job will run maybe in 30 minutes, which means you're not going to pay the cloud provider $10 because you run less. Your cloud provider will charge you based on your time. So if you run half the time, you should pay half the price. You should pay not 10, you should pay $5 to your cloud provider. But equally, Databricks will take a little bit of a premium because you're using a feature of the platform. So you're not going to pay 10, you will pay 12. So your total cost is no longer 20. It's become 12 plus 5, that's 17. So you're going to pay $17. So really, Photon saves you money when you run it. This is, of course, like an unrealistic example. The cost saving is up to, I think, 30%, 40% in some situation, maybe more. So Photon is really optimizes your cost in a ways that you don't even know how it does. But this is how it calculates the cost, and how Photon actually reduces your, we call it total cost of ownership, TCO. How you should use Photon, that's easy. That's actually the most easiest part. You go here to your Databricks cluster. You can actually convert an existing cluster to use Photon. Or when you create a new cluster, this is the tick box. Use Photon acceleration. You take this box and you see your DPUs gone up a little bit. Let's make it actually without auto scaling. So without Photon, you pay 6 DPUs. Let's choose something actually very fake one. So you have one node, you weigh 1.5 DPUs. With Photon, you weigh 3 DPUs, like double the number of DPUs, but equally you will get almost way less cost from the vendor, from the cloud. So your total cost of ownership is way less. And that's how Photon runs. Now, should you use Photon for every workload? No, not really. Photon is only useful when your workload does a lot of CPU processing. CPU, right? So your CPU is busy doing crunching of your data, maybe doing maximum, minimum. Whenever you find aggregation, joins, minimum, maximum, average, this kind of stuff, group by, this is CPU intense operation. Photon will give you very good performance on this. But sometimes you have an IO bound jobs. You do a lot of reading and writing. Photon have a native writer, or K reader and writer, which is also fast. But the main benefit of Photon when it's CPU bound, it's not network bound, it's not IO bound, it's CPU. My advice is always try Photon first. If it gives you good performance, go for it. If you didn't notice a much better performance without Photon, then yeah, don't use Photon. But most of the time you'll find Photon very helpful and useful to you. So that's it for this lesson, and see you in the next lesson.